Now in this lesson, we're going to look at system of equations. We're going to identify what a system looks like, or a system of equation looks like. And we're going to solve them by substitution, and then we're going to solve by elimination. Now a system of equations has two or more equations that need to be solved together in order to identify the unknown terms. And each system has two or more unknowns that need to be solved for. Let's look at a few examples of systems. I can say x plus y equal to 4 and 3x minus 2y equal to 7. This is a system because I need both equations together to be able to identify the unknowns or solve for the unknowns. You can also have more than two terms. You can have x plus y plus z equal to negative 3, and then x plus 2y minus 3z equal to 12. So in order for you to solve this, and then we can also have a third one, 2x plus 3y minus 4z equal to negative 6. So this is a system here, and then this is another system. Notice that the systems look similar, the equations look similar for them to be part of a system. Now we're going to look at substituting or solving equations by substitution. And what we're going to do with this is we're going to express one of the variables in terms of, we're going to solve for one of the variables and then use that to substitute in the other equation. So let me show you how that is done. So here this is a simple example. Here y equal to negative 3. So because I'm going to use substitution, in the second equation I am going to now have negative 5x minus 3, and then we're told y is negative 3 equal to 14. So we have negative 5x plus 9 equal to 14. So now we're going to solve for x. We subtract 9 here, we subtract 9 here. So negative 5x equal to 5. So we divide by negative 5 and divide by negative 5. So x equal to negative 1, and we already know that y equal to negative 3. So that's how we solve by substitution. Now let's try out this one here. We have 3u plus z equal to 15, and then u plus 2z equal to 10. So we can pick whichever one we prefer. So we can either solve for z in the first equation, or we can solve for u in the second equation. So let's solve for z. So I can call this equation 1, I call this equation 2. So from equation 1, z equal to 15 minus 3u. So I'm going to substitute this value of z. We're going to substitute z into equation 2. So now we have u plus 2, and then for z we have 15 minus 3u equal to 10. So we have u plus, now we distribute 2 into this expression, 30 minus 6u equal to 10. So now let's combine common terms. U minus 6u plus 30 equal to 10. Can subtract 30 here, subtract 30 here. So u minus 6u equal to minus 20. So minus 5u equal to minus 20. We divide both sides by minus 5. So u equal to 4. Now we're going to substitute that into the value of z right here, this equation right here. So we now see that we're told z equal to 15 minus 3u, which is 15 minus 3 times 4, which is 15 minus 12, which gives us 3. So therefore, u equal to 4, z equal to 3. Let's try one more. We have 6x plus y equal to 18, 5x plus 2y equal to 22. I always believe in using the simplest way to get to your answer. So I'm going to solve for y in the first one. So y is equal to 18 minus 6x. And then we're going to substitute that into the second equation. So 5x plus 2 times 18 minus 6x equal to 22. So we're going to simplify 5x plus 36 minus 12x equal to 22. So let's group common terms. So 5x minus 12x plus 36 equal to 22. So negative 7x plus 36 equal to 22. We subtract 36 from both sides. So now we have negative 7x equal to negative 14. And then we divide both sides by negative 7. So x is equal to 2. So the next step we're going to take is we're going to substitute that this x equal to 2 back into this equation here. So y is equal to 18 minus 6x, 18 minus 12, which is 6. So therefore, x equal to 2, y equal to 6. That is pretty much how you deal with substitution. Now let's look at elimination. When you're dealing with elimination, we have to determine what variable we want to eliminate, and then we're going to multiply the equation by a specific number so that we have the same value on both equations for that specific variable. Now, let me show you what that means. So we have 3a and 2a here. We have 5u and u here. So it's easier for me to convert u to 5u than deal with 3 and 2. So what I'm going to do here is I want to make this u right here 5u. So I'm just going to multiply u by 5. So because I multiply u by 5 to get to 5u, I'm going to multiply the whole equation by 5. So I'm going to multiply this by 5. It's going to give me 10a plus 5u equal to 45. Now there are two ways to go about it. One way is to make sure that they have different signs so you can add, but then there's also another way that if you leave them as the same sign, you can always subtract. So it's really up to you what method you prefer to use. So I'm going to show you this method, and maybe in the next one I'll show you the other method. So now our equation now becomes 10a plus 5u equal to 45. We also have 3a plus 5u equal to 17. So we have 5u and 5u here. So we can subtract the equations. So 10a minus 3a, that's going to give us 7a. 5u minus 5u is 0. 45 minus 17 is 28. So we divide by 7, divide by 7, a equal to 4. Now we can we will substitute this value of a equal to 4 into any of the equations we prefer. I'm going to use this one right here. So 2 times 4 plus u equal to 9. 8 plus u equal to 9. So we subtract 8 here, we subtract 8 here. So u equal to 1. So therefore, a is equal to 4, u is equal to 1. Now for this example, I am going to use the other method, which is make sure that when we're done choosing the term to eliminate, they have opposite signs. So we look at this, we have 6 here, we have 3, we have 2 here, we have 3. So you can see 6 and 3 have a multiple relationship. So because 6 is a multiple of 3, what I'm now going to do here, because I want to make sure that the sign here is different, I'm going to multiply the first term here by negative 2. So that's going to give me negative 4v minus. So we have negative 4v minus 6x equal to minus 16. And then the second equation is 3v plus 6x equal to 15. So we can add them together. So let's put an addition sign here. So negative 4v plus 3v, that's negative v, plus negative 6 plus 6 is 0, and then negative 16 plus 15 is negative 1. So we divide both sides by negative 1 until we have v equal to 1. Now we're going to substitute v equal to 1 into any of the equations we prefer. So I'll try the second one. So 3v is 3 times 1 plus 6x equal to 15. So 3 plus 6x is 15. And we're going to subtract 3 here, subtract 3 here. So 6x equal to 12. We divide by 6, divide by 6, x equal to 2. So therefore, v equal to 1, x equal to 2. So that is the solution for this system. Finally, we're going to use whichever one we prefer. I like keeping the sign the same and then subtracting where necessary. So here I'm going to solve for y. Look right here. So when you're dealing with this, you want to compare both terms and see, or both set of terms and see which one would be easier to work with. You know what? Instead of using y, I'm going to use x this time around so I can show you the other way when you have this type of scenario. So we have 5 and 6, so we're going to find the lowest common denominator of 5 and 6. That's going to be 30. So to make them the same, I'm going to multiply this right here by 6, and I'm going to multiply this right here by 5. So let's get at it. So 2y times, so we're going to multiply this by 6, so that's going to give us 12y plus 30x equal to 78. The bottom is going to be 5y plus 30x equal to 50. And then same sign, so we're going to subtract 12y minus 5y, 7y equal to 78 minus 50, 28. Divide by 7, divide by 7. So y equal to 4. Now I'm going to substitute y equal to 4 into the second equation. So 4 plus 6x equal to 10. Subtract 4 here, subtract 4 here. 6x equal to 6. Divide by 6, x equal to 1. So what we have is x equal to 1, y equal to 4. So this is generally how you deal with system of equations, the elimination method as well as the substitution method. Feel free to determine which one you prefer and use them, and you can be consistent with it while you're doing your tests.